The load calculation appears generally correct, however the final breaker size may need adjustment. We will break down each step of the calculation to ensure accuracy. Firstly, the room addition is calculated at 540 square feet times 3 volt amps per square foot, equaling 1620 volt amps. Secondly, the kitchen square footage is accounted for with 2 appliance circuits of 1500 volt amps each, totaling 3000 volt amps. Next, individual high-load appliances are considered. These include a refrigerator at 1500 volt amps, a microwave at 1500 volt amps, an island square footage allowance of 1500 volt amps, and a freezer at 1500 volt amps. Lighting in the room addition is calculated as 8 can lights at 60 watts each, totaling 480 volt amps. The total load without the double oven is calculated by summing the individual loads. 1620 volt amps plus 3000 volt amps plus 480 volt amps plus 1500 volt amps plus 1500 volt amps plus 1500 volt amps equals 9600 volt amps. A demand factor of 35% is applied to the portion of the load exceeding 10,000 volt amps, but since the total load without the double oven is less than 10,000 volt amps, the entire load is subject to the 100% demand factor according to the NEC. The previous calculation uses 35% for the load rating. This is incorrect. This means 9600 volt amps plus 0 volt amps equal to a total of 9600 volt amps because there is no rating to apply with the load being below 10,000 volt amps. The double oven load is 7.2 kilowatts, which is converted to 7200 volt amps. The total load is calculated by adding the load without the double oven and the double oven load. 9600 volt amps plus 7200 volt amps equals 16,800 volt amps. The breaker amperage is calculated by dividing the total load by the voltage. 16,800 volt amps divided by 240 volts equals 70 amps. The closest standard breaker size is 70 amps, not 60 amps. In summary, while the individual component calculations are accurate, the application of the demand factor and the final breaker selection should be revisited. The calculations result in a suggested 70 amp breaker, but the original calculation suggests a 60 amp breaker. It is critical to select an appropriate breaker size based on the load calculation and in accordance with the NEC. The 60 amp breaker may be undersized given the actual calculated load. Always consult the NEC and local electrical codes for specific requirements in the area. When calculating loads, firstly, determine the general lighting load. Secondly, calculate the small appliance and laundry loads. Thirdly, account for individual appliance loads. Fourthly, apply any applicable demand factors. Fifthly, determine the total calculated load. Sixthly, select the appropriate overcurrent protection device. The NEC provides guidance on load calculations in Article 220. It is important to follow these guidelines to ensure a safe and code-compliant installation. A subpanel is an additional electrical panel that branches off from the main service panel. It provides a convenient way to distribute power to specific areas of the house, such as a room addition or workshop. Subpanels are particularly useful when the existing service panel lacks sufficient space for additional circuits, or when you want to isolate circuits for specific purposes. When installing a subpanel, safety should be the top priority. It is essential to follow all applicable electrical codes and regulations, and to consult with a qualified electrician if needed. Firstly, disconnect the power to the main service panel before beginning any work. Secondly, select a subpanel with an appropriate amperage rating for the intended load. Thirdly, install the subpanel in a dry, accessible location. Fourthly, run a properly sized feeder cable from the main service panel to the subpanel. The feeder cable should consist of 4 wires, 2 hot wires, a neutral wire, and a ground wire. Fifthly, connect the feeder wires to the appropriate terminals in both the main service panel and the subpanel. Sixthly, install circuit breakers in the subpanel to protect individual circuits. Each circuit breaker should be sized appropriately for the intended load. Seventhly, label each circuit breaker clearly to indicate which devices or outlets it controls. Finally, test all circuits to ensure that they are working properly and that there are no shorts or ground faults. A proper grounding system is essential for electrical safety. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding system should consist of a grounding electrode, such as a ground rod or metal water pipe, connected to the service panel with a grounding electrode conductor. All metallic enclosures, such as electrical boxes and appliance housings, should be bonded to the grounding system with grounding conductors. When installing a subpanel, it is important to ensure that the grounding system is properly extended to the subpanel. This can be done by running a grounding conductor from the main service panel to the subpanel. The grounding conductor should be sized according to the NEC. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock. GFCIs monitor the current flowing through a circuit and detect any imbalance between the hot and neutral wires. If an imbalance is detected, the GFCI quickly trips the circuit, cutting off the power and preventing electrical shock. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor areas. They are also recommended for use with portable tools and appliances. When installing a subpanel, it is important to install GFCIs in any circuits that will serve wet locations or portable equipment. Arc fault circuit interrupters, or ASIs, are devices that protect against electrical fires. ASIs detect arc faults, which are dangerous electrical discharges that can occur when wires become damaged or loose. When an arc fault is detected, the ASI quickly trips the circuit, cutting off the power and preventing a fire. ASIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. When installing a subpanel, it is important to install ASIs in any circuits that will serve these areas. Electrical codes are sets of rules and regulations that govern the safe installation and use of electrical equipment. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to follow all applicable electrical codes when installing a subpanel or performing any other electrical work. Local electrical codes may be more stringent than the NEC, so it is important to check with the local authorities to determine the specific requirements in the area. Permits are often required for electrical work, including the installation of a subpanel. A permit is a document that authorizes you to perform electrical work and ensures that the work is inspected by a qualified electrical inspector. Permits help to ensure that electrical work is done safely and in accordance with applicable codes. Before beginning any electrical work, check with the local authorities to determine whether a permit is required. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical work is done safely and in accordance with applicable codes. During an inspection, the inspector will examine the wiring, grounding, and other electrical components to verify that they meet the requirements of the electrical code. If the inspection is successful, the inspector will issue a certificate of compliance. It is important to have all electrical work inspected to ensure that it is safe and code compliant. When planning a room addition or kitchen remodel, it is important to carefully consider the electrical needs of the new space. Determine the number of circuits that will be required to serve the lighting, appliances, and other electrical equipment in the room. Calculate the total load on each circuit to ensure that the circuit breaker is sized appropriately. Consider the placement of outlets and switches to ensure that they are conveniently located and meet the requirements of the electrical code. Plan for adequate lighting to provide sufficient illumination for the various activities that will take place in the room. Consider the use of energy-efficient lighting fixtures and appliances to reduce energy consumption and save money. Kitchens typically require a number of dedicated circuits to serve the various appliances, such as refrigerators, dishwashers, and microwave ovens. It is important to provide adequate circuit capacity to meet the demands of these appliances. Island counters often require outlets for small appliances. The NEC requires that tile and counters with a width of 12 inches or greater have at least one receptacle outlet. These outlets should be GFCI protected. When installing wiring in a room addition or kitchen remodel, it is important to use the correct type and size of wire. The size of the wire should be based on the load that it will carry. The type of wire should be suitable for the environment in which it will be installed. For example, wiring installed in a wet location should be rated for wet locations. All wiring should be installed in accordance with the NEC. Wiring should be properly supported and protected from damage. Electrical boxes are used to enclose wiring connections and protect them from damage. Electrical boxes should be made of metal or plastic and should be sized appropriately for the number of wires and devices that will be installed in them. Electrical boxes should be securely mounted to the wall or ceiling. All wiring connections should be made inside electrical boxes. When making wiring connections, it is important to use the correct type of connectors. Wire connectors should be sized appropriately for the size of the wire. Wire connectors should be installed tightly to ensure a good electrical connection. All wiring connections should be made in accordance with the NEC. When working with electricity, it is important to take safety precautions to protect yourself from electrical shock. Firstly, always disconnect the power to the circuit before working on it. Secondly, use insulated tools to prevent contact with live wires. Thirdly, wear rubber gloves and shoes to provide insulation from the ground. Fourthly, never work on electrical equipment in wet conditions. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Remember to use the correct wire gauge for the amperage of the circuit. Refer to NEC Table 310.15b16 for ampacities of insulated conductors. For example, a 20 amp circuit typically requires 12 gauge copper wire. A 15 amp circuit typically requires 14 gauge copper wire. Larger appliances like ovens and ranges may require larger gauge wire, such as 8 or 6 gauge, depending on their amperage. Conduit is a protective tubing used to enclose electrical wiring. It can be made of metal or plastic. Conduit provides physical protection to the wires and helps to prevent electrical shock and fire hazards. Conduit is often used in exposed locations such as unfinished basements or garages and in underground installations. Different types of conduit are available for different applications such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Select the appropriate type of conduit for the specific installation requirements. When running conduit, it is important to follow the NEC guidelines for fill capacity. The fill capacity refers to the maximum number of wires that can be installed in a particular size of conduit. Overfilling conduit can cause overheating and damage to the wires. Use a conduit fill chart to determine the appropriate size of conduit for the number and size of wires being installed. Outlet spacing is another important consideration when planning electrical installations. The NEC requires that receptacles be installed so that no point along a wall line is more than 6 feet from an outlet. This ensures that extension cords are not used excessively, which can create a safety hazard. In kitchens, receptacles must be installed at each countertop that is 12 inches or wider. These receptacles must be GFCI protected. Lighting is an essential element of any room addition or kitchen remodel. Proper lighting can enhance the aesthetics of the space and improve its functionality. Consider the different types of lighting available, such as recessed lighting, pendant lighting, and track lighting. Choose lighting fixtures that are energy efficient and provide the desired level of illumination. A lighting plan should take into account the different activities that will take place in the room and provide appropriate lighting for each activity. Dimmers can be used to adjust the level of lighting and create different moods. Smart home technology can be integrated into the electrical system to provide automated control of lighting, appliances, and other devices. Smart home devices can be controlled remotely using a smartphone or tablet. This can provide convenience and energy savings. Consider installing smart switches, outlets, and thermostats to enhance the functionality of the electrical system. Surge protection is important to protect sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. A surge protector diverts excess voltage away from the equipment, preventing damage. Surge protectors can be installed at the service panel to protect the entire electrical system, or they can be installed at individual outlets to protect specific devices. Dedicated circuits are often required for appliances that draw a large amount of current, such as refrigerators, ovens, and air conditioners. A dedicated circuit is a circuit that serves only one appliance. This helps to prevent overloading the circuit and causing a fire hazard. The NEC specifies the requirements for dedicated circuits. When installing a dedicated circuit, it is important to use the correct wire size and circuit breaker size. Electrical safety is paramount. If unsure about any aspect of electrical work, consult a qualified electrician. This review clarifies key points and ensures a safe and code-compliant electrical installation.